You clicked because something is building out over the water right now, and you can feel it in the way the forecasts keep changing. Good, because they are changing. Here is what I need you to understand in the next few seconds. The signal I have been watching in the data points to a storm capable of rapid intensification, the kind that forecasters at the National Hurricane Center define as a jump of at least 35 miles per hour in wind speed, inside a single 24-hour window. That is not my opinion. That is the threshold the National Hurricane Center itself uses, and the ocean conditions I am seeing right now are the exact fuel that process needs. I checked the sea surface temperature maps this morning before I had even finished my coffee, and I actually sat back in my chair because the numbers over the water were higher than I expected for this point in the season. Stay with me, because near the end, I am going to show you the one measurement. Almost every news channel skips a number about the heat hidden deep beneath the surface, and it is the single detail that decides whether this stays manageable, turns into something we talk about for years. Wherever you are watching from, this affects how much warning you will actually get. Let me walk you through this the way I have been tracking it, hour by hour, because the timeline is the whole story here. Start with where we are right now. The thing about a developing storm is that the moment it looks impressive on the map is almost never the moment it became dangerous. The danger is decided days earlier, out over open water, in conditions no camera can show you. And that is exactly where the current setup gets my attention. Right now, the ocean surface across the warmest part of the basin is sitting at temperatures in the range of 86 to 88 degrees Fahrenheit. To put that in plain terms, tropical systems generally need water of at least about 79 degrees Fahrenheit to form and hold together. We are not near that floor. We are far above it. The ocean is running hot enough to act like an open fuel line. And that matters because of a simple rule of physics that meteorologists have understood for decades. A hurricane is, at its core, a heat engine. It pulls warm, moist air up from the ocean surface. That air rises and cools and releases enormous amounts of energy, and that released energy lowers the pressure at the center, which pulls in even more air even faster. The warmer the water, the more energy available. The tighter and faster that engine can spin. So when I see surface water this warm, this early, I am not looking at a curiosity. I am looking at the difference between a storm that peaks as a modest system and a storm that overachieves every forecast in front of it. But here is the part that keeps me up at night, and it is the piece most people scrolling past the headlines never hear. Warm surface water alone is not the whole story. If it were, forecasting would be easy. Let me show you why the surface can lie to you. When a storm sits over the ocean and churns, it does something called upwelling. The powerful winds drag the top layer of the sea around and pull cooler water up from below. In a normal situation, that cooler water reaches the surface, robs the storm of some of its fuel, and puts a natural ceiling on how strong it can get. That is the brake pedal. The ocean usually keeps pressed, and understanding exactly how it works is what separates the people who act in time from the people who wish they had. If you want to go even deeper into how these systems are tracked, interpreted, and what the data actually means before it reaches the headlines, I have written about it at length in Storm Signal, Storm Intelligence, and Storm Alert, a series of digital books built around exactly this kind of sourced, mechanism-level understanding of how these storms work and how to read the warning signs yourself. You can find them linked in the description. If you already think this way, those books were written for you. Now, with that foundation locked in, let me take you to the atmospheric side of this, because the fuel in the ocean only becomes a catastrophe when the atmosphere stops fighting back. Now, here is the question that decides everything. What happens when there is no cooler water underneath to pull up? What happens when the warmth does not stop a few feet down, but runs deep, 30, 60, 90, even more than 150 feet below the surface? Then the brake pedal is gone. The storm churns and keeps pulling up warm water instead of cold. The engine never gets starved. And that is the exact condition behind almost every terrifying, headline-making, rapid intensification event of the last decade. Think about what happened with Hurricane Michael in October of 2018. It crossed a patch of deep, warm water in the Gulf and reached the Florida Panhandle as a Category 5, with sustained winds near 160 miles per hour after forecasts days earlier had suggested something far weaker. Think about Hurricane Ian in 2022, which strengthened dramatically before striking southwest Florida. Think about Hurricane Milton in 2024, which exploded over the Gulf of Mexico with one of the fastest intensification rates ever recorded in that basin. In every one of those cases, the surface temperature told part of the story. The heat hidden below the surface told the rest. So the piece I am tracking most closely right now is not just how warm the top of the ocean is, it is how deep that warmth goes. And I will come back to that, because it is the finale, it is the number that reframes this entire situation. But first, let me move the clock forward, because the next stage is where the forecast either calms down or begins to snowball. Here is the setup that turns warm water into a real threat. Warm ocean is the fuel, but a storm also needs a favorable atmosphere to organize. And the single most important atmospheric factor is something called wind shear. Wind shear is the change in wind speed and direction as you go higher into the atmosphere. When shear is high, it tears the top off a developing storm, tilts it, and keeps it from stacking into the tall, vertical, symmetrical column it needs to strengthen. High shear is the atmosphere fighting back. When shear is low, the storm gets to build straight up, unobstructed, like a chimney with a perfect draft. And the forecast guidance I have been reading suggests a window where that shear relaxes right as the system moves over the warmest water. Do you see the problem forming? Low shear plus deep warm water plus a moist atmosphere is the recipe. It is not a mystery to forecasters. It is the exact combination the National Hurricane Center flags in its discussions when it starts using cautious language about the potential for strengthening. And I want to be precise here, because I do not do vague fear. When forecasters talk about rapid intensification, they are talking about that specific threshold. I mentioned winds increasing by at least 35 miles per hour in 24 hours. But the ocean and atmosphere can do far more than the minimum. There are documented cases where storms have gained 50, 60, even more than 70 miles per hour of wind speed in a single day when everything aligns. Hurricane Otis, off the Pacific coast of Mexico, near Acapulco, in October of 2023, is the case that shook the entire forecasting community. It went from a tropical storm to a Category 5 hurricane in roughly 12 hours, catching official forecasts almost completely off guard, and it slammed into a major city with almost no time for people to prepare. That is the nightmare scenario for a forecaster. Not the strong storm you can see coming for a week. The strong storm that assembles itself overnight, right before landfall, when it is too late to safely leave. So the question I keep asking the data is simple. Is this system going to be the slow, readable kind or the overnight kind? And to answer that, I do not rely on the surface maps alone. I wait for the aircraft. Let me tell you about the people who fly straight into this. While the rest of us are watching satellite loops, there are crews flying directly into these storms. NOAA operates hurricane research aircraft, and the United States Air Force Reserve flies the 53rd Weather Reconnaissance Squadron, the group known as the Hurricane Hunters. They fly into the center of these systems and release instruments called dropsondes, small sensor packages that fall through the storm on tiny parachutes, radioing back pressure, temperature, humidity, and wind at every level as they descend. Why does this matter to you? Because satellite estimates can be fooled. A storm can look ragged from space while its core is quietly tightening, or it can look impressive while it is actually falling apart. The aircraft data is the ground truth. It is the difference between a guess and a measurement. And the number those crews chase more than any other is the central pressure. As a storm strengthens, the pressure at its center drops. a rapidly falling central pressure measured directly by aircraft is often the earliest hard confirmation that intensification is underway, sometimes before the wind field even catches up. So when I am tracking a system that has the ocean heat and the low shear lined up, the first reconnaissance flight into it is the moment I stop speculating and start knowing. Therefore, the timeline I am watching is not just about days on a calendar. It is about specific checkpoints. The first is the ocean setup, and that is already in place. The second is the shear window, which the models suggest is opening. The third is that first aircraft pass that confirms whether the pressure is dropping. And each checkpoint we clear narrows the forecast and raises the stakes. But before I take you to the last and heaviest piece, I need to stop and talk directly to a specific person watching this. Maybe you live nowhere near a coast. Maybe you are inland, hours from the nearest beach, and a small voice in your head is saying, this whole thing is about somewhere else, about people on the shoreline, not about you. I need you to hear me clearly, because that assumption is exactly how people get caught off guard, and this next part is built specifically for you. The single deadliest part of these storms is very often not the coastal wind. It is the water, and the water travels inland. Let me explain what the science actually shows, without hype. When these systems come ashore and slow down, they dump staggering amounts of rain far from the coast. The National Weather Service has repeatedly documented that a large share of fatalities in these events come from inland freshwater flooding, not from the storm surge at the beach. Rivers and creeks that look harmless can rise many feet in a matter of hours. Roads you drive every day become channels. And the classic preventable tragedy is the person who drives into water across a road at night, misjudges the depth, and is swept away. It takes only about 12 inches of moving water to float many vehicles, and roughly 2 feet to carry away most of them. That is why the National Weather Service repeats the phrase, turn around, do not drown. So here's what you can actually do right now, wherever you are, based on exactly the science I just walked you through. First, find out if you live in a flood-prone area before anything is even threatening. The Federal Emergency Management Agency maintains public flood maps you can look up for free by typing in your address. It takes a few minutes, and it tells you something the news never will. Whether your specific street sits in a zone that floods. Second, know your elevation and your nearest waterway. If a storm's remnants are forecast to stall over your region and drop many inches of rain, the creek 2 blocks away is your early warning system, not the coastline on television. Third, sign up now for your local emergency alerts and make sure wireless emergency alerts are enabled on your phone. Those are the messages that will wake you at 2 in the morning when a flash flood warning is issued for your exact location. That warning is worthless if your phone is silenced and you never opted in. Fourth, and this is the one people skip, decide in advance what triggers your action. Do not wait to feel scared. Decide today that if your area is placed under a flood watch, you move anything valuable off the ground floor, you fill your gas tank, and you charge your devices. Pre-deciding removes the panic and the fatal hesitation later. None of that requires you to live on a beach. All of it comes straight from what the National Weather Service and the Federal Emergency Management Agency actually recommend. And all of it matters more the moment a storm like the one I am tracking starts feeding on the kind of ocean heat we are seeing. Which brings me back to that ocean heat, and to the number I promised you at the very beginning. Because here is where most coverage stops. And here is where the real story lives. When you watch the news, you will hear the wind speed and the category. You might hear the sea surface temperature. What you will almost never hear is the measurement that forecasters themselves quietly obsess over. It has a name most people have never encountered. It is called ocean heat content. Ocean heat content is not the temperature at the surface. It is the total amount of heat stored in the water column down to the depth where the ocean cools to about 79 degrees Fahrenheit. In other words, it is a measure of how deep the fuel goes. And it is measured in units scientists write as kilojoules per square centimeter. You do not need the math, you need the concept. The higher the ocean heat content, the more warm water is available before the storm can churn up anything cold enough to slow it down. And here is the threshold that matters. Research, going back to studies after some of the worst hurricanes on record, has repeatedly identified a value around 90 kilojoules per square centimeter as a rough danger line. When ocean heat content climbs above that level along a storm's path, rapid intensification becomes dramatically more likely because the brake pedal I described earlier, that upwelling of cold water, simply cannot reach the surface. There is too much warm water in the way. Now, here is the part that reframes everything. The detail I sat with this morning that I could not stop thinking about. In the warmest parts of the basin right now, there are pockets where the deep warm water is organized into features the ocean scientists track by satellite altimetry, essentially measuring tiny bulges in the height of the sea surface that reveal where warm water piles up deep. Below. In the Gulf, the most notorious of these is the Loop Current and the warm eddies that spin off from it. These are rivers of deep warm water, and their ocean heat content can run far past that 90 kilojoule danger line into values that have historically supercharged storms into monsters. This is exactly what happened with Hurricane Katrina in 2005 and Hurricane Michael in 2018. Both crossed deep warm ocean features and both intensified explosively right before landfall. The surface temperature barely changed as they crossed. The heat that mattered was underneath, invisible to the eye, visible only to the instruments. So the single most important thing I am watching is not the wind speed the news will show you tomorrow. It is whether the projected path of this system runs directly over one of those deep pools of high ocean heat content. Because if it threads across that deep warm water during the low shear window, the models and the physics both say the same thing. This system has the room to intensify faster than the forecasts released a few days earlier will have predicted. And that is the trap. The official forecast is a snapshot. It updates every few hours, but human beings anchor to the first number they hear. If the early forecast says a moderate storm, that is what sticks in people's minds, and they plan around it and they do not check again. Meanwhile, the storm crosses the deep warm water, the pressure crashes, the winds jump by that 35 miles per hour or far more in a single day, and the version of the storm that arrives is not the version anyone remembers being told about. You do not have to fall into that trap. Now you know the one measurement to ask about. When you read an update, look past the headline category and ask the real question, what is the ocean heat along the path? And is it above that danger line? The data exists. NOAA publishes ocean heat content maps publicly. The people who fly the aircraft know it. The forecasters writing the discussions know it. Now you know it too. Let me tell you how to actually find the truth faster than the headlines, because this is the whole point of watching to the end. Do not rely only on the polished television graphics. Go one layer deeper to the same place the professionals go. The National Hurricane Center publishes something called the Forecast Discussion for every active system. It is written in plain text by the on-duty hurricane specialist, and it is where they explain their reasoning, where they say things like the environment is conducive to strengthening, or where they warn that the intensity forecast may be conservative given the ocean heat content. That word conservative is the tell. When a forecaster writes that their own forecast may be conservative, they are quietly telling you the storm could outrun the numbers on the map. That is the sentence I hunt for in every discussion. It is the professional's way of raising an eyebrow. And most people never read it because it is buried in a text bulletin instead of shouted on air. So here is your move, and it costs you nothing. When a system is threatening your region, read the forecast discussion directly, once in the morning and once at night. Watch for that shift in language. Watch for mentions of ocean heat content, of rapid intensification, of low shear, and cross-check it against the ocean heat maps. If those three line up, deep warm water, relaxing shear, and a forecaster hedging that the intensity could be underdone, you do not wait for the evening news to catch up. You act on your pre-decided plan. That lead time, even a few extra hours, is the entire difference between an orderly preparation and a desperate scramble. That is the edge. Not fear, not panic, just the same information the experts use, read a little earlier, understood a little deeper. Let me pull it all together because the timeline is still moving as you watch this. Right now, the ocean is running hot at the surface, well above the threshold storms need. Below the surface, in the pathways these systems love to follow, there are deep reservoirs of heat that can blow past the danger line and erase the ocean's natural break. The atmosphere appears to be opening a window of low wind shear right as any developing system reaches that fuel. The hurricane hunters stand ready to fly the first passes that will turn speculation into measurement. And the forecast discussions are the place where the professionals will tell you, in careful language, if they think their own numbers are too low. Every one of those pieces is real. Everyone is verifiable. Everyone is sitting in the public data at NOAA and the National Hurricane Center and the National Weather Service right now. Whether or not the headlines have caught up, what I want you to carry away is not dread. It is the calm confidence of someone who understands what the machine is running on and what to watch as it spins up. You are no longer waiting to be told what is happening. You know where to look, you know the one number that matters underneath the surface, and you know the exact word in a bulletin that means the professionals are worried. If you are the kind of person who would rather read the source and understand the mechanism than wait for a scary graphic to appear on the evening news, then you already think the way this channel thinks. That is the whole reason I do this, to get the real, sourced picture to you before it becomes a headline, back when there is still time to act on it. So here is what I want from you, and I want you to actually do it. Tell me one thing in the comments when you look up the ocean heat content along a storm's path, or when you read a forecast discussion for the first time. Does it change how seriously you take the forecast? And tell me where you are watching from, your region, your state, your country, because I read those comments and it helps me understand how this looks near you and who needs the warning most. Say it plainly, right now, before you scroll away. If you want the next update, subscribe not to support me, but to stand with the people who want the sourced version first while there is still lead time to use it. Because the next thing I am tracking is that loop current itself, and how far north that deep warm water has already pushed this season. If the number I am seeing holds, the next system that crosses it will have more fuel than anything we should be comfortable with. And I will bring you that data the moment the instruments confirm it, straight from the source, before it reaches the news. Before you go, if this video helped, there's a deeper version waiting for our members. You can ask me your own question and a real person answers, and you'll be among thousands of folks just like you. Point your phone's camera at the code on screen. It takes less than a minute, and you can cancel anytime, no risk.